kick this off. I hope you can see the slides. Um, so we're going to talk a little bit about um, why we are doing this, like why secure the AI models. The first reason is if you think about the AI model, it's a it's actually an opaque binary, right? So you don't really know what kind of risks you are um, uh, being exposed to unless you are able to provide more insights to that model. Unfortunately, the way that the models are, you cannot really get that from the model binary itself. And then there are a lot of real world incidents that has happened and probably are continuing to happen uh, uh, in regards to AI ML artifacts. For instance, poisoned data is a known problem where um, models are trained with data that has been deliberately poisoned with nonsense. And there is a lot of third-party weights that people may be using unverified. There is a lot of IP that could be stolen. And then on top of that, there are the compliance and audit requirements that are coming in or exist. Like the GDPR and HIPAA is two, if you are familiar with those. They apply to applications, but they do apply to AI/ML or applications that are using AI/ML. And then new ones, unfortunately, it's cut here, but there are new ones that like the EU AI Act, the ISO 42000, and so on and so forth. So there's an NIST one. I think I'm missing a few others. Some of them are not that heavy, but some of them do require evidence, essentially. So, in the securing the supply chain is not something that is new to us, right? We have been doing this with our software in the past, and we have decades of experience essentially trying to get our supply chains in a acceptable state. And if you think about how we are doing software supply chains, it's like you have your source, your build, you once as a result of your build, you sign them, attest your SBOMs into them, and then you deploy, right? In the AI/ML world, this is you have your data, your training, which gives you model weights, and then you deploy your model weights. Of course, if you're doing agentic AI, this gets a little bit more complicated, but let's start with the very basic case of the uh, very basic case of using models. So today, uh, most of the time, the AI/ML artifacts go live with as opaque binaries. Like there is no trusted metadata that is used during deployment time. Like if you think about the life cycle here, you have your model weights, but then there is no metadata or some limited metadata, and that metadata cannot be trusted. And of course, policy enforcement and is not in place, and that's because you can't really enforce any policies on opaque binaries. And then auditability is, in some cases, it exists, but it's very little and covers only certain uh, trust boundaries. So what would this look like, right, in a secure pipeline for AI ML? And I'm overly simplifying this for our purposes, essentially. Um, First of all, you need to do data ingestion, right? You have your data, you need to do data ingestion, and there are a lot of techniques for and products essentially for um, keeping the data lineage and secure and um, uh, during ingestion. So, and this talk doesn't really cover the data ingestion part. And then you do your model training, and then the next thing that happens is you do your packaging. And in here, we basically are going to talk about packaging your AI ML artifacts as model kits. And because of the properties of the model kits, we will be talking about attestations and signing. And using these attestations and signing, we're going to talk about policy enforcement um, and and eventually deployment and runtime. So I'm going to introduce an open source project briefly because we're going to talk about model kits. So KitOps is a CNCF hosted open source project. It basically transforms an OCI registry, your Docker container registry, into a full-featured model registry. Uh, as I said, it uses the existing container registry tooling. It uses the existing container registries themselves. It is based on the OCI specification, which is one of the fundamental cloud native standards out there. So essentially, what it does is it transforms your AI ML into a cloud native um, uh, environment. Uh, I mentioned model kits, so let's see also think about what or talk about what model kits are. So model kits are OCI artifacts. That means that they are like Docker images, but they are not Docker images. Docker image, like the way I think about it is Docker image is an instance of an OCI artifact, although chronologically Docker images came before the OCI artifacts. That's why, but if in an ideal world we would actually have OCI artifacts and Docker images would be one type of OCI artifact. And model kits is a second type of OCI artifact. And there are other OCI artifacts out there that you can find. For instance, the Helm charts can be packaged as OCI artifacts. They have their own um, OCI artifact definition. Um, well, who else is doing that? I think the WASM actually can be packaged as OCI artifacts. The policy files can be packaged as OCI artifacts. Anything that you want to have immutability and security can be packaged as OCI artifacts in that sense. So model kits provide a specification of how that packaging should happen. What should be the media types and how you package them, how you define them. So it's a definition of the OCI artifact essentially and the accompanying tooling for it. One thing that we are doing lately as part of CNCF is to create uh, a specification that is based on essentially model kits, which we call them model packs. It is a collaboration with us, Red Hat, um, Alibaba, and Docker is kind of about to join or have some inspirations to join. Yeah, it's like the model kits are kind of turning into more open collaboration specification at this point. So where does KitOps or the model kits touch to your pipelines, right? We talked about the ideal secure pipeline or secure supply chain, and uh, the first place is once you did your training, right? Once you did your training pipelines, your experimentation is done, you want to package your um, AI ML artifacts into a model kit. So that's the first touch point. Another thing that happens that is kind of parallel to that is not all AI is trained nowadays. You kind of use them from existing base models, and that's the kind of the import flow that you can have. Uh, then the second touch point is your registry, right? Where do you store them in a secure, immutable way? Where do you store these artifacts? So that's your registry. That's your essentially Docker container registry. It can be ECR, it can be Google, it can be, we have one in Jozo.ml, it can be that. So that's when you do the push. And then during deployment, you do a poll or unpack, depending on your use case, to use your models. And during all these touch points, we're going to talk about that a little bit. You can do a little bit of verification and and adhere to secure supply chain best practices. So first, we're going to look at how we can do packaging and how we can do signing. So we're going to do something, and of course, we're not going to train a model today, but what we're going to do is we're going to import a model from Hugging Face into a model kit. So we're going to go with the import flow. And then, but you could also do a pack command as well. And then, as I said, because you are now in the OCI specification, you're in the world of cloud native, you are able to use existing tools to work with the model kit. So we're going to use an existing tool called Cosign to sign our um, model kit with a signature. So I guess this is the point where I try to do a demo of what I was saying. But is everything clear until this point? Are there any questions that I am actually missing on the chat? Because the chat window is completely in the wrong place right now. I can't see it. All righty. So I'm gonna stop my share a minute and switch to command line. Unfortunately, I was really frustrated with the fact that I can't share the whole screen. So I have to do the switches. All right. So what were we doing? We were going to do our first demo. So I'm going to just use my cheat sheet here so that you don't see me typing all day. But yeah. All right. So the first command is we're going to do is a kit import. And let me find the name of the yeah. So the kit import command takes a repository, essentially a Hugging Face repository URL, and then you can just use a tag to tag this locally. Let me just tag it with something. Again, let me just copy and paste this so that I don't have to type it all the way. Yeah. So once you do this, what it will do is it will go to Hugging Face, take a look at the repo, and give you a suggestion for what we call a kit file, right? So a kit file is essentially similar to Docker file, but it is a declarative way of saying, hey, these are the things that I want you to package into the model kit. So at this point, the kit CLI, what it did is it went to the Hugging Face, looked into the repo, and then determined that, oh, these are the model files. As you can see, they actually have multiple weights here. So like there's a safe tensor one, and then there's H5, and I can see, do they have the Rust one as well? I don't see it. Maybe they do. But typically, you see multiple weights in a kit, in a Hugging Face repo. So what this can do is you can actually modify this and say, oh, you know what? I don't really want uh, this. I don't want H5 either. You know, uh, code, who cares? You know, I just want the license and the README here, and you can change the name of it, or and so on and so forth. So, and then once you're done, um, this is horrible. I can't see what I'm typing. It will save it there and then start downloading it, you know, and creating these um, uh, this model kits out of it. So let's not watch this because I actually did this before. So let's go do the cooking show. But if we do a kit list, you will see that I actually did the um, I thought I did. I have so many of these that I can't even see what the one that I'm looking for. Okay, let's just do, oh, we have seen this, but another thing that we can do is to do this a different way. We actually support two flows of importing from Hugging Face. As you know, Hugging Face is essentially a Git repository with large file support. What we do is we directly use the Hugging Face's APIs normally, but in some cases that may not be feasible. So what we do is we give you a way to use the regular Git flow as well, as a way to download from Hugging Face and use that for creating your model kit. Let's see if, and of course this flow is going to take a little bit longer because it actually just downloads everything up front and then um, packages them afterwards. But yeah, let's not package everything maybe. All right, now this is packaged and now I should see it when I list it. As you can see, it's now here. Ah, what did I do? It's now here. All right, now next step is to push this to a repository, right? I'm gonna just take this. So this is my local one, and I'm gonna push that to a repository on jojo.ml. And just for fun, I'm gonna introduce you to a uh, little so we have our cherry uh, uh, progress bars, which are they look like Pac-Man, but of course this is too quick for that probably. But yeah, so that's the the part where now our uh, local model kit is now pushed to our registry, and now our next step is to use the cosign to sign it. And to do that, I'm going to create key pairs. Yeah, of course it exists. Why not? So we have the key pairs that we want to use to sign the packages. The other interesting thing that you can do with Cosign is if you don't want to have um, public-private keys, you can also sign them with an OIDC provider like Google, GitHub. That also that's actually the keyless signing that you can also try to use. So now we're gonna do a sign, but for this, I'm gonna again copy and paste so that we're not spending time watching me type. So what this will do is it will use the key we just created and sign the package on the registry and push the signature to the registry as well. Because it needs to push the signature to the registry, I'm gonna give it my username and password. Of course, I actually set my username and password to an environment variable so that we don't publicize that everywhere. Uh, I don't know why it's doing this. So, of course, my password was completely messed up. I have no idea why, because I'm doing demos, right? That's why. What I'll do is I'll do and then the rest here. So now it's generated the signature and it's pushing it to the registry. As you can see, it's in there. And if we want to verify it, we can also use Cosign's verify um, to verify what we just did. With the public key. As you can see, the key that I have just used is the public key. And to see what give us better, let's do this. So as you can see, it retrieves the signature, verifies it with the public key, and gives us a little information about, they are validated, uh, and they are verified against the public key and all that information. All right, now that we have done a demo, let's go back to our slides so that you can have the joy of doing this yourself. All right, so we're gonna basically do the same altogether, um, the two things that you need is the Kit CLI and the Cosign. The URLs for them are here. Let me see if I can make this better by putting these URLs to Zoom chat. If I can find the chat. Oh, sorry, I didn't see the terminal size. Uh, I'm just noticing it right now. All right, so these are the places where you can install the Kit CLI and the Cosign CLI. And once you have them, uh, we're gonna do what I basically just did in a minute ago. You will need access to a container registry. This can be GitHub, this can be Docker, whatever your it is. And if you want, you can use jozu.ml, which will give you a little bit more flair for model kits. It's our service that is essentially optimized for model kit usage. And in our exercise, we're going to do patch a public model using the KitOps port, generate a cosign key pair, um, sign the model kit, and verify its attestation and signature. And I also actually have a cheat sheet here with the commands that I have used today to so that you can um, take a look at them and inspired. And now I'm realizing that this is actually really long. Which is something I can fix while you guys are working on um, installing the CLIs and getting your um, registry accounts up and running. I think I got my Cosign through Brew actually. Um, but let me check that again. Yeah, Homebrew actually has Cosign. Yeah, if you prefer that. Okay, I updated the cheat sheet a little bit so that it's not cut off at the end. Um, a simple texture runbook of a sort. I can give you the this cheat sheet if that helps. Um, but this is the, I guess this makes it easier for you to copy and paste. I'm pretty sure the names will be different. Um, the one thing that you will have to do, which I haven't done here, is the Kit login command. You need to log into the uh, your registry. Um, if you're familiar with Docker login, it works the same way. It's Kit login and then your registry name, and then it will prompt you for your username and password. or we can pass them as username and password as parameters to the login command. With Cosign, you don't need to log in ahead, but it does require a register username and password when it is pushing the sign, the signature to the registry. So how are we doing with the exercise? Anything, any questions, anything I can help with? How many of you have logged into your model kit registry with kit login? Anyone who passed the import? You can import without logging in. It will just do that locally, so there is no login requirement. But to be able to push to a registry, you need to log in before the push command. Anyone who has been using Cosign for their applications in the past. Okay. Someone's waiting for the mail to arrive. Let's see if I'm sitting on the cable or not. Sometimes the mail providers, they're not as fast as they should be. So Scott is asking, why would we use Joja Hub here? It's not an something that you must do. It's just any container registry will do. It's the one that we run. Uh, so, and Jesse is one of the founders of Jozu. So, uh, understandably, he's anxious to get more people to try Jozo ML. But there's no, it's not a requirement. It's just uh, alrighty. Uh, nice. Nice. So we got to do push and the cosign in where should be a breeze as well. But I'm gonna start moving a little bit um, to the next slides where we talk about um, a little, I don't know, how's everyone feeling? Uh, are you close with the exercise, or do you want me to wait a few more minutes and then we talk about a little bit about attestations? All right. Let's talk a little bit about policy as code. Um, what they are, where they are coming from. If you have ever used the uh, the policy agent or the OPA gatekeeper or some tool like Querno, you can define policies as code, essentially something like Q or Rego files, and you can give rules uh, for your containers and your configurations in your Kubernetes clusters. But this doesn't have to be tied to the Kubernetes. Essentially, you can do it in different places. Uh, a good example is proxies have um, uh, Rego policies that allow them to manage the traffic and whatnot. So one thing that, for instance, you can imagine doing is if you have a model kit uh, that has a verified attestation that you can use to um, enforce a rule, then you can use these existing tools like the gatekeeper or anything. of that sort, um, to enforce policies into AI ML artifacts. This is something that you cannot do with the bare AI ML artifacts because you don't really have um, uh, these sort of trusted metadata as a concept on the bare AI ML models. One interesting thing I want to show on Josu ML that we do is we have these are my demo models, and they are marked unsafe because they are not safe. So don't use them on prod if you don't want me to have your AWS or AWS secrets. There's a security report here. This tab is essentially rendered out of an attestation. So what Josu ML does when you push a model into Josu ML is behind the scenes, it does scanning for code injection errors in certain model formats like pickle and so on and so forth, and then gives them generates a report which it attaches to the model kit as an attestation. So what that means is now you can verify this security report's critical level not by talking to JoseML because it is attached to the artifact itself, which is the model kit itself. So you can just do that on anywhere in your pipeline to avoid deploying harmful models or training based on harmful models and whatnot. But you can imagine this is just a security report. You can imagine more things to um, attest as well. So what kind of tools you're able to use? Once you have model kits, as I said, you can use the Cosign keys and transparency logs. Uh, the one thing that Cosign does is it actually uses Sigstore's record to also record transparency logs. So that gives you two immutable places where um, your attestations are recorded. And then you can have Rego policies, and there are multiple tools out there that have either Rego or Q or some other format for defining policies. But at the end of the day, all these tools are very comfortable working with OCI artifacts. And as a model kit is an OCI artifact, they usually don't have any issues with that. So, and this next one, we are going to pack a model from a folder and sign it the model kit, and then attest it with a custom attestation, and then verify the attestation. That's our exercise for the next 40 minutes. Of course, I'm going to run through that a little bit uh, myself as well. The tools that we are going to use are not any different. This time we're going to use the, again, KitCLI to do the packaging and the Cosign for signing an attestation. Um, now let me again do my little dance with the windows. If I can find the correct window. No, you're not seeing my terminal area. Hmm, now it is. And let's get this a little bit larger. How's it now? Is it better? First I'm asking, but I can see the chat window. Alrighty. Okay, so we're gonna do a model pack. We're gonna package a model pack from a um, local folder, essentially. So that we can see, how to do that in locally as well. And before we do that, let me get my little cheat sheet so that I don't type everything. All right. Let me just show what I have locally here. So in here, you see that I have two folders, the Llama model, which is a Llama 3.2 LLM. And then there is another model called wine quality. So if we look at the wine quality one, because that's the one I want to uh, package today. You see there's a lot of artifacts in it. One of the things that you will notice that there's a data in there. It's a CSV file. That's actually the CSV file that we use to train this model. And then there's a pickle file, which is the trained weights. But on top of that, we used MLflow and MLflow runs. So we saved some of the run artifacts into the model kit itself. Also, there is the notebook that we used for training and also for testing. But but this could be anything essentially. It could be an LLM that you are packaging as well. So if you look at the um, Llama model, you can see that there is a Giga file on that one, for instance, and you can just package that uh, as a um, as a model kit. Alrighty, so let's package this into a model kit. And if you are wondering where you can get this wine quality model, it is available on jozu.ml. So you can just do a kit pull and it you can just pull it and try it yourself as well. Um, let's give it a name, a tag. Okay. And once we have this, it should go and package it. It did package it, but of course it said, oh, I already have that layer. So one of the interesting things about Kit is it never duplicates data. So if you have ever packaged a model kit, because this is content addressable storage, we know that we already packaged it, so we don't package it again. We just refer to it locally and some of the repositories also do that. This is because although this particular example is not very large, but there are, as you can imagine, very large models out there. There are very large data sets out there where you really do not want to replicate the data and be uh, careful with it. I'm not going to, if you have generated a Cosign key pair before, you can just reuse them for this exercise as well. But if you haven't, you do want to create a Cosign key for this exercise as well. So let's do the push to the registry. And obviously I'm better at typing than copying and pasting. So now this is pushing the model kit we just packaged locally into the remote repository. Again, I'm using the jozu.ml Jozu Hub, but you can use any model registry at this point. So all right, now I'm gonna show you a file because we're going to attach an attestation to this model that we just pushed. And the attestation, usually the attestations that you attach is something like a salsa provenance attestation or, a well-known format. Unfortunately, the well-known formats for AI and ML are very limited. Uh, okay, it's not limited. It's pretty much non-existent. So uh, therefore, in this exercise, I'm going to just show you something that I have written. It's a JSON file um, here. And what it does is it basically just the results of the ML flow run, and it gives you a accuracy score in a JSON format. It's like, oh, these are the metrics. Here's my accuracy score. Here's my example count, and so on and so forth. So what we are trying to do is essentially record the results of the experimentation as an attestation to the model kit so that this is a trusted metadata that can be used down the line for policy enforcement. All right, let's do our cosign. This time we're not going to use the sign command. This is the attest command, and of course our key. Uh, of course, we did the predicate, which was the attestation JSON that we just looked at. And since we are using the registry, I'm going to just copy and paste that. And so that we can push the attestation back to registry. This is really important that we are able to push these things into an immutable storage, which is the registry itself. This way, we are basically guaranteeing that they are not tampered with. On top of that, these are also signed with your private keys on this case, but as I mentioned earlier, you can also do this with keyless signing. Let's fix that. All right. Um, so what it is doing is it's going to sign the attach the attestation to the model kit that exists on JosuML. The reason why also it's asking me to verify that I want to share my personal data is because it puts a public transparency log into Sigstore's record database. That's why it's asking about it. Uh, and in there you actually have your um, username, no, not password, of course not, no, but the signature, uh, the public signature, and so on and so forth in there. So right now this is attested. So let's see if it is attested. What this one is doing is it's actually using the public key to retrieve the attestation. As you can see, let's run this through. Okay, what it does is it goes into the registry, retrieves the attestation, and verifies it with the public key. As you can see, it gives you a small report of, oh, I have verified this with the public key. And by default, Cosign uses the Toto envelope for uh, packaging the attestations. And as you can see, the payload is the base64 encoded version of that JSON that we just had earlier. So if I actually just take this and I don't know if this is because of the Zoom, my terminal is acting in ways that it shouldn't. Yeah, I can see. But trust me, it's in there. And if you want um, to also implement policies against that, you can also do that as well. For instance, tools like OPA have a way of running regos against OCI artifacts, and Cosign also has a way of doing this. So let's take a quick look at what would that look like. Like it could be as simple as this, where you have an allow rule that says, hey, if the metric score is larger than this value, it's um, you can you can uh, validate it. So um, when you put all of this together, from packaging it local model kit, which is your um, training pipeline, and then you next attach an attestation, which is your training pipeline has some results that you want to attest into the model kit, uh, provide that trusted metadata, and then down the line verify it using Cosign. You know that it's the trusted metadata is there. That's your first step. And now you can what you're able to do is you can now add enforcement rules on top of that trusted metadata to enforce, go no go decisions, deploy, don't train kind of decisions in depending on where your pipeline is. The great thing about all of this is you're now in the cloud native space with all your deployment decisions and policy enforcements, and all of these are done using the standard tools. All right, let's recap. One of the things that is good about model kits and the way we package them, the AI ML artifacts, is it doesn't only bundle the model weights. As you have seen with the wine quality um, model, it bundles code, it can bundle weights, it can bundle data sets, but also it bundles the metadata. And because the OCI artifacts are immutable, it encourages the reproducibility as well. So you don't have to worry about, oh, where was the data? Where did it go? Which code was used to create this weights? Because you know that because they are packaged together and it's a immutable package, you never lose that relationship between different artifacts that creates that is part of the model kit. The second thing that we looked at is policy as code. In order for you to do automated governance, and by automated governance, I mean, it's like not without tribal knowledge, where it's like, yeah, that model is not good. Don't ever deploy that into production, but rather, capture that as policies and enforce them on trust boundaries, when you're doing deployment, before deployment, when you're doing training, and those sort of boundaries. Then you need metadata and you need trusted metadata. So that's the second thing that we looked at and that the model kits can provide for you. Of course, it sounds like no-brainer when you think about model kits and OCI, but if you think everything else in the AI ML world where there are no signatures, attestations, there is no verifiable trails that you can use, the auditable artifacts is a big step forward for creating a secure supply chain for your AI ML. And of course, the end-to-end flow, you train the model, you package it, sign it, enforce anything that you need to enforce. If you want to enforce signed model kits, if you want to enforce certain attestations, enforce that, and then deploy that to production. There are two things that you can look at. The KitOps.org is the open source project. You can there's a lot of information on how to use KitOps with different tools, different methods, and KitOps also has additional commands that we haven't covered in this workshop that you can look at. And Sigstore is a very good resource for securing your supply chain, especially with Cosign, signing and attestations. It's basically what Sigstore specializes in. All right, thanks everyone for attending. This was hopefully useful to everyone, and have a good day, good night.